Alright, today's topic is called Reciprocal Function. And this is the way you're going to see it written. So this is 1 over the value of f of x. F of x is the fancy way of saying y.
They just say y.
Okay, so if I reciprocate 2/5, it becomes 5/2. If I reciprocate the number 10, it becomes 1/10. If I reciprocate -4 over 3,
3 over -4. -3 over 4.
I don't care where the negative is, but the value is still negative. You can't switch negatives and positives. That's not happening. If you reciprocate 1 over 50, 50. If you reciprocate 1,
It'd still be -1.
it'd still be 1.
Oh, it does look at it.
Because 1 over 1, that's what it would turn into, which is just 1. What about the reciprocal of -1?
That means -1 over 1.
Still -1. Because 1 over -1. The reciprocal of 100? 1 over 100. And let's save the best for last. What happens if you reciprocate 0?
Error.
1 over 0. So I hear no solution, I hear error. You're on the right idea, but undefined is the word I use.
Error and undefined would be the same.
Because it's like me saying, what's the number? You can't say your number is error. You can't say your number is no solution. So the number is an undefined value. Okay, so we're going to be graphing this. So if I ask you where to put 50 as a height, you know where to put 50 height. If I say where's 1 as a height, you know where to graph that. How do you graph an undefined height, undefined? How do you graph that? You draw up and down like that to say, I don't know where y is. I don't know the height. The height could be anywhere. And there's a special name for something like that. And it's a really weird word. Here it is. Asymptote. Asymptote. Oh, you're going to graph and graph those in grade 12. Lots and lots. So it's an asymptote. And it's a vertical asymptote. Okay, so basically when we're going to do this, we're going to have 3 major rules. So if I have a height of, basically a height of 1 or -1, we're going to stay the same. Does that make sense? Because if I reciprocate 1, it didn't change. It was just 1. If I have a height of 0, 1 over 0 is undefined, which means I'm going to draw an asymptote. The bigger your value is, so a big number like 100, what's the reciprocal? The bigger this number is, the reciprocal will be smaller. If you have a small number, the reciprocal will be big. That's an opposite relationship. So I should have actually written this differently. I don't like big and small. I like move towards 0. If you're going to move towards 0, your reciprocal will move away from 0, and vice versa. So if you are going away from 0, your reciprocal is going to go towards 0. You're going to ask me something? No, you're just like stretching. Okay, let's see what happens. I got 2 graphs for you. Okay. So what I'm going to do first is find any heights of 0. So I see a height of 0 right there. So I'm going to, now I'm going to draw an asymptote. Because when I change the height of 0 and reciprocate that, 1 over 0 is that. Okay, now I'm going to look for heights of 1 or negative 1. So where do you see a height of 1? Right there. A height of negative 1. So those coordinates would not be moving. Okay, now the third portion is to fill in the pattern. So for instance, I'm just going to take one coordinate and show you. This coordinate would be 3, 2. And I'm going to change that coordinate. And how am I going to change it? It's going to become 3, 1/2. You see what I did? I reciprocated its height. I'm changing the height. So the coordinate 3, 2 becomes, how do you reciprocate 2? 1 over 2.
How would you do 2 only one side?
Well, there's no graph over here. I'm just taking a coordinate on my graph and changing it. Okay, let's fill in the rest of the graph. I just took one sample of a coordinate. Okay, if I look in this zone right here, so I'm looking from this to this, the graph is going what? It's moving how? Closer and closer to 0. So what should my new graph do? Move away from 0. Okay, I'm going to talk about this zone. From here, what's happening? As I go, what's happening? I'm moving away from 0. So what should my new graph do? Go towards 0. Yeah.
How about maybe explain again where you replicated the 3, 2.
Okay, so do you see that that's a coordinate 3, 2?
Yeah.
Okay, and what's this about? It's reciprocating the height.
Yeah.
So I just look at the 2. How do you reciprocate 2? 1 over 2. So the new height is a half. Okay, now the situation has caused me to do something here. Because this graph, you're telling me that I'm going to go closer and closer and closer and closer and closer to 0 here, I've actually created another asymptote because I did that. In a graph, if you ever are getting closer and closer and closer and closer to something but not getting there, It's an asymptote. Okay, so let's talk about this side now. Okay, do you see what the coordinate is right here? What's the name of this coordinate? How would you call that? 0, -2. Where would you want to move that coordinate if you reciprocated it?
0, comma, it's negative 1 over 2.
0 doesn't change, but I reciprocate this. So the new coordinate is a height of -1/2. Okay, now I'm going to talk about what's going on from here to here. This section gets closer, closer, closer to 0. So what am I going to do? I'm going to shoot away from 0. Then I'm going to analyze this part of the graph. As I'm going on this part of the graph, I'm shooting away from 0. So I will now move towards 0. Okay, second graph. So I'm going to start. Asymptotes are there. There's an asymptote. And here, because I found heights of 0. And when I try to change those heights, I just don't know where to put them. So you have 2 asymptotes. Okay, now we're going to analyze 1, -1. So points that stay put. Actually, there's 4 points on this graph that are not going to move. Can you figure out 4 points that won't move? So anytime I had a height of 1, anytime I had a height of -1, I keep a point there. Okay, let's do this middle section, the little V part. Okay, tell me the coordinate that would be at the very bottom there. 1, -4. So where would it be on my new graph? 1, -1/4. Okay, so does this make sense if I say this originally was the lowest point? So now it's going to be the highest point, right? Because everything always makes it opposite. Can you fill in what you think the pattern might do? Because obviously you have to connect your points together. So you can see it better. So thinking about your sections, I had a little section when I went closer to 0, so then I shot away from 0.
What is square thing?
What the little section that I would talk about would be like this little section. That little section there, you're getting closer to 0, so then that's what I did instead. I shot away from 0. From this to this, I went towards a height of 0. So now my graph goes away from the height of 0. Is that what you're looking at? Okay, now we'll go here. Okay, so this point on this graph is the highest point. 1, 2, 3, 4, 5, 6, comma 6, 6. So it was the highest point. Now in that section, it's going to become the lowest point. So what's the new coordinate? 6, 1/6. So the highest point becomes the lowest point. Now what? Can you make sure you're gonna go through your coordinates and then you're going to shoot up away from 0. Okay, you know what? I think the other side is the exact same, but can you mirror that idea? You know what I mean with mirroring it? This opposite side is going to mirror. Okay, now here's some special notes. On the first graph, I had an arrow, and look what happened. There was an arrow, and then we had to have an asymptote there yet. On this graph, there was no arrow. My graph would also stop. Now I don't need an asymptote there, because it doesn't keep going.
So why does it keep going up?
Because of this. If this keeps going up forever, this will keep getting closer and closer and closer and closer and closer to 0.
Then what about the other graph?
This one stopped, completely stopped at a height of 6. So this one completely stops.
Then why are there arrows on the highlighted lines on that?
On like this,
Yeah.
because this region gets closer and closer and closer to 0. So this will go away, away, away from 0, but there's no specific ending. So if I think about my height, this is like 1/10. Now this height is 10. Like it's going to go fast. It's like 1/50. Look how fast I'm shooting up to 50. Okay, and then some notes here. If this is an asymptote, that shows me that you're working your way towards an asymptote. If this is an asymptote, this person looks like their graph is curling away from the asymptote. I don't want that. What?
Being facing it or being equal to it?
Like look at how I'm just curling.
Yeah, but like, do you want the ones that are correct, do you want them to be facing the line, or do you want them to be like parallel with the line when they get to that point?
Well, you mean like this?
Yeah, like, do you want them to be going up with it, or should they be pointing in?
They need to be kind of going up with it.
Right, okay, yeah.
Yeah. If you mean versus like this?
Yes.
Yeah, this is kind of sketchy because I'm like, well, where are you going? Are you like angling this way?
Right. Okay.
That's a questionable. This is excellent. What if somebody drew this? No, that's a bad. You're never allowed to touch an asymptote at all.
Edgy.
You're never allowed to cross through it. So asymptotes on graphs, you always get really close to them and kind of go along them because you're just getting continually closer and closer and closer to them. That's what they're there for.